Welcome, Pascal. Thank you for joining us today. So could you give a brief introduction to yourself, the field that you're in, and how long you've been using containers?
Sure. So I'm Pascal Elahi. I was a computational astrophysicist and did my PhD in astrophysics. And I'm currently now a member of the Pawsey Supercomputing Centre, working on helping scientists port their code to supercomputers to enable new science, essentially using more of the machine as they can. And in terms of my experience with containers, to give a bit of context, in astrophysics, specifically computational astrophysics, we are very heavily involved in software development and typically don't have workflows that are so complex to require containers, but it does happen. And often the best use case is usually data analysis, where we're trying to take some data, reduce it, do some plots, possibly use a variety of different ways of plotting and visualizing data and analyzing data. And because of that complexity, right, if you think of that workflow where I have some input data, but then I want to do 5 things to it and then maybe branch off and do some other interesting things to it, that workflow can involve a variety of different programs, different languages, from Python to R. And doing that type of analysis where it's kind of a bit complex and ensuring that you have everything you need to do that analysis, especially on computational resources that are not just your own laptop where you have full administrative privileges, usually does require a bit of thinking. And one of the ways to get around that thinking and make your life a little easier is a container, where you essentially go through and carefully say, I know that I need these programs. I go through and I try to find out how I install it, construct a container, have a nice image, and then launch that image to then essentially use stuff like Jupyter Notebooks or RStudio and do some processing and do the plots that you'd be interested in doing. Not having to worry about making sure that everything is available. And for people who are somewhat familiar with trying to do some plotting in Python or in R and using some specific packages, it's non-trivial to keep track of everything you need and making sure that all dependencies are met. And so my experience has been trying to use containers and also help other people use containers for that context, saying I know I want to do some exploration of data, and I want to try a few different things, and one of those things requires A, and the other thing requires B, and the other thing requires C, and I don't want to have to think about it too much. I just want to be able to write a quick little script and then get an outcome. And containers is one way of kind of bypassing all that to make your life maybe a little bit harder initially, because you have to think about it, but then once it's done, not having to think about it again, and having that be portable everywhere. So you can just go, I have my container, I have a nice image, I put it somewhere.
I know that I can at least do A and B and not have to think about it too hard.
Okay, thanks. So take me back to when you first started, your first exposure to and work with containers. What problem were you specifically looking to fix or address? And then what were your initial challenges with using containers? Like, what was the hardest thing to try to overcome?
So when I first started using containers, I should preface that also my background at that point had been already quite a bit of software development. So my level of entry to containers is that I knew how to program in a bunch of languages, and I was very familiar with Linux. And so the threshold for some people might be slightly different if they're very new as well. So I came at it trying to essentially use 3 different routines, 3 different packages for doing a specific set of data analysis, one involving machine learning, one involving nice plots that I liked, and one involving kind of manipulating data in a particular type of fashion. So those, but it was all in Python. However, one of the routines that was a nice library that could do analysis to the side was R. So it required a different language. And in this case, it was just going, okay, well, I want to make this a bit easier on me, and I don't want to have to necessarily generate essentially a containerized environment everywhere I go. I just want to kind of do it once. So the idea was to then try to make a container that had all the Python packages I want, plus the R that I needed. And then that way, this portable little virtual environment, this container contained everything I could do. So I could then go into, launch it and write Python run script and not have to worry about imports failing. So the idea was to try to make sure that I've met dependencies. That was the hurdle I wanted to overcome, and portability, to make sure that I didn't have to think about it again. The entry point was just learning the Docker syntax. So I was using Docker as a way of constructing my containers. and kind of getting used to how it manages container and images was sort of the main initial hurdle, just going to figure out this is how it's doing it. And this is how I can then interact and build up on previous work that I've done before. And working around that, I mean, Docker provides a nice way of doing it. So it's just a way of figuring out the concept of how it constructs an image. And then once I was done, I had an image and I could move it around.
Okay. And what would be one or two key pointers that you could offer or you would offer to somebody who's starting with containers to kind of be that tipping point of, do I use them or do I not use them?
Yeah, so I would say the one of the key tipping points would be is if you ever have to run, if you ever think you will run whatever workflow you have elsewhere other than one specific place. And if that workflow has, let's say, 3 bits to it, right? 3 non-trivial bits to it, where you have to say, I'm grabbing some package here and some package here and some package here. And you know that on your laptop you could install stuff, then you maybe need to start considering containers, because it's a way of overcoming all those hurdles, not having to think, oh, I don't have a way of installing stuff on a new system. And also, what do I do to install it again? I can't remember how I installed it. There's maybe different ways of installing software depending on the environment you're in. For context, like in Windows, you have an executable, it launches an installer. In Mac, you have these DMG files, but you can also do something else involving package management like Homebrew. Linux has a different ways of installing packages. Remembering all these things and figure out what to do, again, could be a hassle if you have to keep porting stuff and making sure that you reinstall and reinstall and reinstall. So if you can do it once, do it once. Especially if the once is, if the many times is hard. If you have to do it many times but it's super simple, then maybe a container isn't necessarily the process for you. But if they require some thought, then, and you're going to do it more than once and you might have to port it around, then I would say that that's a good place to think about starting using containers.
Okay, thanks. And we'll wrap up with one final thought of wisdom that you would like to pass along to new container users.
Right. So I'll offer 2 phrases of wisdom, or 2 ideas of wisdom, which is if you are starting to develop your own containers, one is in that sort of idea of building your own containers, document what you do, because you can obviously write files that say specific instructions, and it's very common to see them just do the instructions, but write the stuff for yourself saying it's doing this. Give yourself some notes. And make use of containers that exist already. So don't, reinvent the wheel. The wheel in a container, if it's like you wanted this version of this language and it's somewhere out there, you're not going to do anything more. It's going to be exactly the same, essentially. So don't reinvent the wheel and look for it. For using containers, the same thing sort of applies in terms of reinventing the wheel. Have a search for seeing what is available before you think I've got to go down the path of building my own, because someone else may have done the work for you. And that's great.